Hey everyone, I think I'm live now. One second. I think I'm live. I just hope you guys can see my screen because I don't think you guys actually can. Which is weird because you should be able to be. You should be able to see my screen. One second. You know what? Give me a second. Let me just take a look. See if. Alright, okay, cool. Okay, hey everyone. Uh, Welcome back to another stream. And we just streamed yesterday, and it was a fun stream. We got a lot of work done, and today my goal is to either finish up or almost finish up on the project of our projectile motion. Alright, so that's kind of what the goal of today's stream is. Uh, yeah, I just, for some reason, my display wasn't visible on the stream earlier. I don't know why that happened, but whatever. Alright. I was saying that I might have done this stuff via just a video, but I figured that since I started out with the stream, I would actually just stream the entire process because I also wanted to show you how, you know, you should go about doing something like this kind of live so you have a decent understanding of how to code stuff like this. So, yeah, that's kind of the reason. Alright, so you know what, everything aside, let's actually get started working and let's actually start making this entire thing. Alright, that's awesome. I'll just open up my terminal. I'll be using NeoVim just like I did yesterday. First, my goal is to just show you what we have in place right now. Now, if you remember, the last two lines of code that we added, wherein we changed the exchange of the player, that was actually very important in a way. The reason why I say that is because if I add those two lines of code, look at the result that we get. I actually haven't run it, I was just imagining what the result should be. So you can see the result is a projectile motion. Oh, yeah. That's kind of what I wanted. Alright, so I know it doesn't really look that pretty. So in this video, my goal is actually, because I haven't actually told you what the goal is for the video, and like I've kind of briefly touched upon what I wanted to make in this stream, but I still haven't actually given you a concrete thing. So my goal for this stream is to first of all create a kind of a line that projects from the ball and outwards, and basically you can adjust the length of that line in order to have a different power of the shot that you take. So like a small line means you have a very small velocity initially, and then a large line means like you have a very large velocity. Pretty simple stuff. uh, Now the way I am planning on doing that, because remember the mathematics that we did in the last video where we needed to calculate that little theta. Now in order to calculate that little theta angle, well, I tried to find something that allowed me to resolve a thing into two components in Pygame, but I just could not find something that was you know like in place. I figured out that there were all solutions that were hacky, and I didn't really like those solutions. I figured that there might be a better way. So first, my approach is to just tell you how it is that I'm planning to go about doing this entire line thing, because it took me a second to figure it. It took me some time to figure it out. So I figured, how would I tell you that? But again, I'll probably recommend that if you are watching this stream, after it has been uploaded on YouTube, you pause the video right now and you try to work about how you would counter a problem like this by yourself. And once you get the answer, you can unpause the stream and you can check out the way I figured out. Now, again, this I have no idea if this is like the most optimal way of solving this. I think it's decent enough, so I'm gonna be using this one. But again, it's up to you. And frankly, if you can figure out a better way, then more power to you. Awesome. All right, so I'll just open up the uh, I'll just mirror my iPad display real quick so you guys can quickly see my iPad. All right, there we go. Okay, just a sec. I'll just plug my laptop into charge. Don't want my battery running out during the stream. All right, awesome. Now you can actually get started. Perfect. All right. So, well, imagine we have a vector. So our line is like of some length. Let's say L. For now, I don't really care about what the length is. My primary goal is to just make this these two vectors. For now, I'll just get rid of this, and my primary goal is to find this theta, right? Well, we all know that. All right, so I mean, you know what? I'll just call this u, and we'll just call this uy, and we'll just call it ux. Now, for now, I want you to kind of forget the actual Cartesian coordinate system, and I want you to recall the pygame coordinate system. We all know how the pygame coordinate system works. Is that if you have a screen, then this is 0 comma 0. So I think you can kind of put together all the other coordinates using this, but yeah. So if that is 0 comma 0, how exactly can you define ux? Well, if you are trying to look at the y coordinate of ux, alright, the y coordinate, what should it be? Because my goal is to figure out theta, right? So if I can construct a right angled triangle, and I know what the length of this base and this perpendicular is, then I can figure out, and I know what hypotenuse is as well. So technically, all I really need is the length of either the base or the perpendicular. If I know both, well then that's just gravy. But in reality, I really only need one. But just for the sake of it, we will actually compute both the perpendicular and the base. Actually, in our case, we will need both of them, I guess. We could just calculate one and then use some trigonometry and some Pythagoras theorem to calculate the other, but for now I'm just gonna imagine that I'm calculating both. So one thing that I think you guys could have figured out is that if I simply take this uy vector and I simply shift it to the tip of the arrow of the ux vector, and I connect the u vector to it, it kind of just looks like this, right? It kind of looks like that. Nice. Alright, so over here, how exactly can I figure out the coordinates of ux and uy? What I in reality want is actually not the coordinates but the length of ux. How can I figure that out? Well, it's actually relatively simple. Now, I can see that the ux vector is at this the ux vectors and the u vector's origin, which is here, as the same x coordinate as the rest of the the same y coordinate as the rest of the ux vector. Really, the only thing that changes is your x coordinate. So for the ux vector's length, well, you can just do a simple ux, the x coordinate of ux, or xux minus xu, and you just take an absolute of it, so that kind of gives you the distance. And for this one, well, you just do a simple yuy minus yu, and then you can get both of these lengths. So that's kind of what the approach I want to use looks like. You can, I hope you kind of understood what it was that I was trying to do. All right. So now that we have the approach out of the way, let's actually start programming. And I just want to run this one last time. I want to tweak some of the settings just so that we can get a bit more of a distinct projectile motion, because right now it seems kind of faint. It is still a projectile motion, don't get me wrong. It is following all the laws of the projectile motion. It's just that in order to make sure that you guys can see that it is happening, I'd kind of change some of these things. So I can change the gravity definitely. So instead of 0.08, I can just set it to like 0.04. Actually, yeah, I think that's good. Alright, so for now, that's the setting. Alright, now we can, oops, clear python 3 main.py. Nice. So first, as you can see, our ball goes up, but it's also going there, like, and then it slowly comes down, and it is accelerating. The ball is kind of in the middle. I want it to be at the start, so I'm gonna change the ball x to just like I'm gonna set the ball x equal to just like in terms of the radius. So width minus. So actually, I can just set the ball. I want to set the ball to the left, so I'm just gonna say radius times 2. So now it should be very, very distinct, like what is happening. So you can see the ball is going up, the ball is going up, the ball is going up, and now the ball is going down, 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 down. Isn't that awesome? Physics is just so good. Alright, we have this in place. That's awesome. Alright, okay. Now we need to actually do the vector thing, the vector drawing thing. Before that, I also want to just get the boundary checking in place. I'm going to make a little comment over here. Boundary checking. And this approach I'm not just a big fan of. I'm just going to get rid of it. We're going to rewrite it. So I'm going to say ball y. Okay, I'm going to check ball y. So my first boundary check is just going to be for the bottom of the screen. So since the bottom of the screen is effectively height, I can just say that if ball y is greater than height minus radius, then I'm going to set ball y to height minus radius, and I want to change one last thing, which is that I want to set ball y change equals 0, ball x change equals 0. Now this ball exchange equals 0 is actually not physics logic. That's actually a bit of faulty logic. And I'll tell you why that's faulty. It's a very simple reason actually. The reason why it's faulty is because if you have ever played soccer or cricket, you will see that whenever there is kind of like this projectile motion shot, you'll see that when the ball actually falls down on the ground, you will see that the ball rolls, and even though the ball has lost its y change, it still has an x change. Furthermore, you'll also see that the ball will rebound. We still haven't added logic for rebounding, and I doubt we will. But it's an ambitious goal. But if I can get there, it's just awesome. So let's just check out if this boundary condition works. Alright. So now it should start falling down, 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 down. Alright. Awesome. It just looks so good. Okay, nice. So now that we have the stuff in place, I mean, it could be a good thing to kind of put this code in maybe some kind of a function or something, but I'm not gonna do that. Alright, so okay. Actually, I'm also gonna change one like. Whoa, what just happened? Okay, what just happened? You. Whoa, bro. Come on, man. Why does this stuff happen? Okay, I'm gonna have to just. Alright, I'm gonna paste those 4 lines I don't know. I think I was messing around with my Vim settings the other day. I don't think I should have done that. Especially considering the fact that I know pretty much nothing about Vim script. I'm still trying to mess around with some of my settings. Kind of a dumb thing, if you ask me. Alright, there we go. Okay. Okay. So for now, we'll just keep this. So now our next order of business, as I said, is to draw the line. So I'll go down here and we can draw the line. So line equals pygame dot draw dot line. And I want to see if I can get it correct in just one go. So it should be screen. Okay, actually, no, I'm just gonna look into it. I know the docs do look into that. So pygame dot draw dot line. You can just search for that and you'll kind of get the pygame documentation. Always use documentation. So draw a straight line. We don't want to draw any curved lines and stuff. We aren't playing like Angry Birds or something like that. Alright, so we have line, surface, color, start pause, end pause, and width. So width is kind of like there's a default thing to it, so you kind of don't need to pass it in. Alright. Okay, so you can't have a bit lesser than 1, obviously, because it's in pixels, so you can't exactly do that. Alright, so let's quickly just do that. So we now need a color. Color we'll just set to, actually, you know what, let's set the color to red for now. So we'll just say red equals, firstly, 255 0, we can go down here and we can simply pass red, and then we need the start pause and the end pause. Now for the start pause, okay, so start pause, it's a very simple thing to set. Start pause is just gonna be the ball x, ball y, right? Okay, how do we actually pass in the start pause and pause? So let's take a look at some actual things. Okay, so as I kind of expected, you pass in like this list. So you pass in a list of start pause. Now start pause, again, as I said, it's just going to be ball x, ball y. End pause, for now I'll just say ball x plus 10, ball y plus 10, and for thickness let's just set it to like 4. For now I just want to get a brief idea of what it even looks like, because yeah. Okay, so we have the line showing up. That was my primary goal for now. That's nice. Alright, nice. Alright. Perfect. Okay. So what should we do now? We have this much in place. We have the line showing. Now we need to dynamically figure out the end pause. Alright, so for that we need to get the cursor position, because we know I want to scale this stuff through my cursor. Cursor mouse, whatever you call it. Pygame get mouse. Alright, I'm just gonna say cursor position. Pygame.mouse. Alright, so I'm gonna first get pause. So this is kind of what I wanna. Alright. Okay. What I'm confused about is basically my confusion is in the fact that should the mouse pause be in the thing or not? I guess it should be in here. So we can pretty much just go down here and we can get the mouse pause. So mouse x, mouse y equals pygame dot mouse dot get pause, and for now I'll just say print, and we'll just print it out like a bit pretty in like an F string. So mouse x, oops, mouse y, mouse y, oops. Okay, we'll have to kind of do that so you can get a decent idea. Alright, so that means it is actually working. We are getting these mouse pauses. That is just awesome. Alright, so I'll just make this end full screen again. We know that mouse pause is working, which is exactly what we wanted. So now for the end pause, well, it's actually a very simple thing, because well, we know the mouse x and mouse y, and I pretty much just want to take it till mouse x and mouse y. So it's the mouse x, mouse y. Simple as that, isn't it? Let's run this now. So you can see it is at mouse x and mouse y. That's so cool. Let's go. Wow, it's just so good. Yeah, sure, it can get kind of long and stuff, but for now, I don't really care. My goal is that it should just work. So that's awesome. Another thing that I want to take into account is like the ball shouldn't be moving when the line is being drawn. Like, I don't want the ball to be moving or anything. For now, we shouldn't really care about that. But actually, you know what? I want to have some control over my ball being moving or not. So we can just go down here and we can just say ball moving, and we'll set it to false right now by default. And now what we'll do is we want to draw the line only in a certain circumstance. So if ball not moving, then I want to draw the line. So then I'll draw the line, and that's good. Another thing that we want to do is we only want to change the ball y and ball x if the ball is moving. So if ball moving, okay, I don't know if ball moving, I made a tiny error. If not ball moving, I don't know how I made something stupid like that. Alright, whatever. Alright, that's it. This should pretty much work. Okay, we have an error. Ball moving is not defined. Ball moving. This is not bowling. Ball. And what I'll do is we'll add another event over here real quick. So if event dot type equals pygame dot key down, if event dot key equals pygame dot k underscore a, then we want to set ball moving equals true. So we press the A key and the ball should start moving. A, and we get an error. K underscore A. I'm guessing it's like a lowercase a. Let's just do space bar. Okay. Pygame check key press space bar. Okay, so it's k underscore space. So I got that right in the first go. Run that. Awesome, and we can see that the line also stops showing. That's so cool. Let's go. Yay, that's awesome. All right. Okay, so we have that much in place. I'll take a quick water break. Alright, that's awesome. Okay. Now that we have the line drawing, we can figure out theta. Awesome. So we'll put all of this, that stuff in ball not moving, because I don't want to calculate ux ui when the ball is moving. So okay, how do we calculate theta now? Okay. So I can say that. Okay, what should I do? Hmm. Now the first thing is that, well, currently these are my ux and uis, right? Because this is ux, this is ui. That's at least my guess. Because, oh, so I think since my ux and ui are equal, that's equivalent to the ball being thrown at 45 degrees, I think. So in that case, so in this case, if I set the ux to something that's a bit smaller, let's say 0.5, so actually no, I can't set it to 0.5. Okay, because if I set ux to 0.5 and ui is just 1, then my starting velocity isn't the same anymore. So my starting velocity is root 2, which is 1.4. Actually, no, is it 1.4? Yeah, it should be technically. So if it is root 2, nah, wait, it's 1 plus, it's 2. Yeah, I think my starting velocity is 2. Or is it root 2? Actually, I forgot how. Oh, wait. Nah, wait. It is root 2 actually. And currently, the two components are 1 and 1. And that's how we are forming root 2. Another way, we could do it in different ways. But whatever it is, I mean, this can't be 45, right? So it doesn't matter. If I run this, then technically I should get a much smaller length. So I am correct. So basically that 1 and 1 was like a 45, you could say. Yeah, I was correct. I was correct. That's awesome. Okay, so we'll set that back to 1 for now. Okay, so these are the default settings. So you know what I'm gonna do is we're gonna do that, and we're gonna just repaste it right over here. I'll make a default settings, but in this case we can simply set. So basically I want to do the all the stuff for the line once a key is kind of pressed down, like once I press the mouse key. So check mouse key press by key. Alright, so now we can set a if event dot type equals pygame dot mouse button down, if event dot button equals 3. What should I do now? So for that, what I'm gonna need to do first of all is we're gonna have to put these lines of code above this, so we can paste these here. Okay, that's awesome. And in this case, if that's really happening, alright. So in that case, well, I know what mouse X and mouse Y are. Okay, so what I'm gonna do is actually I'm not gonna do that in there right now. What I'm gonna do is I'm just gonna directly do it over here. So I'll set play ball Y. Alright, what I'm gonna say is velocity Y is equal to, okay, first let's just do velocity X. So velocity X should be math dot abs mouse X minus ball X, and velocity Y should just be oops, math dot abs mouse Y minus ball Y, and then theta should be math dot arctan. We're gonna do arctan of vel y divided by vel x. So that should give me theta. So if I just print out theta, that should be working. That's so cool. If this works, damn, it's just gonna be cool. Okay. Okay, I guess I don't need to use math for the absolute. So we can just do abs. Nice. Arctan. Python math dot arctan. So it's just tan, it's not arctan. Alright, not a big deal. So math dot tan. I've been doing like so much of math and stuff. Alright. Okay, so from what I can see, it's returning a degree measure, or is it like, because it seems like it's returning a, I think it's a radian measure that it's returning, right? I guess that's what it is returning. 1 second. Because that's what makes sense. Because, okay, so 1 second. Wait. Okay, you know what? We're gonna do it a bit differently. When I say differently, I just mean I'm gonna be changing something. So here I have, well, then, okay, 1 second. Okay, we're gonna print it out in this thing. So we're gonna do printf string, and we're gonna print out vx, and we're gonna print out valx, vy, y, theta. Clear that out, and now we can run that again. Oops. Alright, we're also gonna do one tiny little thing, which is that for the initial ball x, we'll set it to radius times 20 for now. So over here, I can see that it is practically 0. Yeah, so we can see that it's always just Vx, it's no Vy, so theta is 0. And basically we go up, and here at like pretty much 90 degrees, where Vx is just 1. Wait a second, Vx is still 1. So, alright, so at 90 degrees we get that division by 0 error. Okay. So we need to figure out a condition for the 90 degrees. So okay, so basically we are making a tiny error, which is that we are using arctan in order to do that, and I should have figured that out for some reason. So arctan is sine over cosine. So in that case, instead of using tan, I should have just used a sine or cosine. And so instead of a tan, we'll just do a sine, and for a sine, we need perpendicular and hypotenuse. So perpendicular is going to be my velocity y, and I'm going to divide it by the hypotenuse. Hypotenuse is going to be just the length of the thing. So alright, so okay, so my well is going to be equal to okay, math dot sqrt. Okay, so it's gonna be okay. You know what? I'm gonna do it a bit differently. So we're gonna just say ball x. Actually, nah. Let's just do a simple thing. So it's we can just do. I'm currently using the distance formula for this. Just saying. So we're gonna do a pow, and we're gonna do 0.5 to it, and we're gonna say pow ball x minus mouse x, comma 2 plus pow ball y minus mouse y, comma 2. Yeah. So this should just be what we are doing here is just using the distance formula, and then we can just plug that in here. So the perpendicular, as we initially figured out, was well y. We divided by well. So I'll just write this down using distance formula to get magnitude of velocity. What we could have used, which was actually, you know what, I'm going to use that because this is a much more complicated and I would say pointless approach. If you look at the approach I want to use, then you'll see that it's actually a bit better. We can simply use Pythagoras theorem on the well x and well y. Am I right? So we can just do a simple okay, so we can just do a simple well x plus we'll have to do this entire thing in a bracket plus well y so we can just do this pretty much just the same thing. So we just do a well y over well, and obviously instead of a tan we want to make it into a sine, I think. So math dot arc sine python. Okay, so it's a sine, just like a tan. Should have guessed, but I just wanted to Google it out. Alright, so we can clear that. Let's hope that we get a theta. That's nice. Invalid syntax. Why on earth is that invalid? I'm guessing it's some sort of a dumb error. Ah, I know. So that was the error. The error wasn't shown on the line that the error really was. Alright, so we get theta, we get theta, we get theta. So at this point, we should get 0. But the reason why we use this is because now if I go right up to a 90 degree, we actually get a measure. Because sine actually never goes off to infinity. Sine has a range from -1 to 1. The tan function on the other hand is actually asymptotic at multiples of pi by 2. When I say asymptotic, it's actually got a vertical asymptote on that. If you don't know anything of what I just said, that's alright. Believe me, I never knew that myself until like very recently, so chill out. Alright, I guess that's pretty much exactly what we wanted. Yeah, it's pretty much what we wanted. That's awesome. Alright, that's awesome. Cool, cool, cool. Alright, so we actually have a velocity. Now, we're gonna have to change the ball exchange and ball y change based on this velocity. Alright, so first off, we wanna set. Actually, another thing that we're gonna do is currently vel x, we are getting the. Actually, wait a minute. I think I'm kind of dumb. Why did I actually get theta? Okay, I mean, apart from aesthetic purposes, when we can tell the user what the theta is, what was the real purpose for theta? Well, in reality, nothing, right? But I mean, come on, you know what? Still, I think it's good. All right. So okay, we have val x and val y. We want to change the ball x and ball y based on val x and val y. So how do we actually do that? Because we want there to be a very, should I say, scaling down mechanism. So like if let's say val x is 20, well then in that case I just want the ball x to be like 0.2, or other than instead of that, another thing that I probably might want to do is to maybe limit the size of the line that can be drawn, because I mean I don't want the line to be too long, because yeah, I mean, okay, so one thing we can do is like this. So if mouse x is greater than ball x plus, let's say 30 for now, then I want to do a pygame dot mouse dot set pause to mouse x mouse y. Actually, no, wait, mouse x, yeah, just that. Nah, not that. Set the pause to ball x plus 30, and we're gonna put this in a bracket for now, so we can just say or not or. So for now you can just set it to that if mouse y is, so I can just say that if mouse, okay, how should I check for that? I wanted to check if it's either above or below, because in that case I have to check for both plus and minus, and I don't want to write two conditions because it's just way too boring. For now, let's just assume no one's dumb enough to aim the projectile downwards. Mouse y is lesser than ball y minus 30. Pygame dot mouse dot set pause mouse x ball y minus 30. I'm just gonna check pygame set mouse pause. So another thing is that we have to pass it in as a list, so that's another thing. That was a tiny error that we have made, so we can pass it in as a list. So effectively that should kind of limit the size of the vector that we are setting. Alright, so dot. Alright, And okay, I mean, so that there's a lot of room for that, but I mean, look, for what we have here, we can draw a vector. It's not very smooth, of course, because I can kind of go very fast over there and it works, but I mean, it's good, it's awesome. I mean, I'm happy with a very, very laggy looking mouse thing. I don't really care about it, but you know, all I wanted was this to actually work. Alright, so now we know that the mouse has been restricted, the mouse movement has been restricted. So, since mouse movement has been restricted, the maximum velocity that you can actually set has also been restricted. Again, I'll just take a quick water break. I'm just gonna say uh, restricting the mouse motion to set a cap on the maximum velocity. So I think that since we are doing 30, we can just divide it by 10. So we can simply just do that and we can divide it by 10. If you want, you could do some sort of an integer division if you wanted a rounded up value, but I'm not gonna do that. I want an exact answer. Actually, nah, let's not do it in vel y and vel x. We can just do what we're doing in vel y and vel x, and then when we are setting y change in that, we'll change that stuff up. The variable names aren't very ideal for that, but you know, I'm still kind of okay. So I can just set the ball x change equals to a vel x divided by 10 and a ball y change equals to a vel y divided by 10. So that should pretty much work. Okay, wow. Also, another thing, you can see that the cursor kind of gets a bit screwed up. Alright, so we're gonna have to add another condition over here. So, and not ball moving and not ball moving, because I don't want to check for this stuff when the ball is moving. I kind of don't care at that point. Okay, so for some reason the ball is just falling down at this point. A reason that I have no idea why. For now, I also want to check one more thing. Print M. I'm gonna click it 3 times. 1, 2, 3. Alright. And of course I don't get it. Okay, maybe I clicked the wrong mouse button because I'm kind of hopeless that way. Alright, 1, 2, 3. Maybe it works now. Who knows? Whoa. I should do something better to limit my. Okay, so maybe it doesn't really work that way with trackpads. You need like a mouse. Kind of sucks, but still, you know what it said. Okay, now for some reason I now need to figure out why on earth is my ball moving all kind of messed up. So for starters, I think that, oh, okay, so I think I know the reason as to why it's so messed up, and I think I also know how to fix that. Basically, if I can set it to something like this, and then I click space. Wow, okay, it still doesn't work. Okay. Ba 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 ba. So I know that whatever reason as to why we are not getting this, it's gotta be. Let me get rid of this. So whatever reason as to why this is not working has got to be in these lines of code itself, because this is where I'm actually changing ball x and ball y. So first off, what I also want to figure out is what exactly am I setting as ball x and ball y. So printf string bx and we're gonna set by. Also gonna remove that from that. Oh, okay. So basically we were setting that to be very very less. So basically ball x and ball y were very 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 small. That does not look good. So in that case, I pretty much just need to make this a bit larger. So I'm gonna set it to 100. 100. I don't really wanna throw around magic numbers, but I really can't be bothered to write very very clean code right now. I should, but I don't wanna. I'm kind of bored in that way. Okay, so in this case, space. Wow, it still doesn't work, but okay, but why on earth does it not work? That's my question. Because I am setting ball exchange and more. Oh, okay. Actually, nah, wait. I think what I was doing initially was correct. The problem is not in there. I have to set that to 30 itself. That's not the problem, bro. 30. Okay, we're gonna change a couple more things. First off, we're gonna. Okay, so if I lower gravity, ball y change can. Okay, so the ball can move up more. So we're gonna change gravity. We're gonna make it 0.02. Maybe just 0.02 for now. I just want to check a couple of things and try to get a decent idea as to why this is not working. So we have this, you can launch it, and for some reason it still just goes down. The weird thing is, it's whatever angle I'm setting this at, it's going down at a very specific angle. So the point is exactly why is that not working? So okay, so how about I print out f. So really I want to do by ball y change bx. We got the math figured out, but I don't know why we can't put it into code. Like, we also got it into code, but for some reason we are not actually able to get a simulation. Alright, so we have this by, we press space. Alright, that's awesome. We actually now have a couple of values. So now I'm gonna do some sort of a quick debugging session on this. Alright, so this all happened sort of after. So one thing we can see is that bx remains the same. So I know that that condition does hold true, which is awesome. Oh, it's such a stupid error. Why did I do that? Okay, I got my error. It's a very dumb one, and I'm gonna hit myself for it. I swear to God, because I just had to set a negative over here. I think that's literally the error. I did not set a negative. Damn, this took us a while. There we go. Okay, another, now not error, but this is kind of my doing, is that I set the gravity to something 2 less. So 0.006 is good for now. Let's run this now. And alright. Okay. Okay, nah, but still, as you can see, it is actually working. So what we're gonna do is we're gonna change this to radius times 3, and then we're gonna run it. So what we're gonna also do is we're gonna run it at a lower y component of velocity. You can see that it actually did start falling down. So you can see that it went from a negative to a positive. So since it went from a negative to a positive, it did start falling down. So it was all right. So we actually have it working. Now we also need to change the gravity. So we're gonna set it to 0.02. Let's check if that is good or not. So let's run it at that. Nice, it's just so cool. Let's go. Alright, so we actually have projectile motion. Bro, you know what? That just looks so sick. It's awesome. I mean, I know for a non-programmer slash non-physics student, this doesn't really mean a lot, and it just looks very boring and very very easy to do. But as you can see, ball physics is not very easy to do. I mean, it is kind of easy, but it's not as easy as I think a lot of you might be thinking it is. Obviously, one thing you can do is clean up the code, because the code right now is pretty bad. Because I mean, this was kind of like a standalone project. It wasn't really integrated into a larger project, so I don't really care what the code is, since this is all that the code has to do, and it doesn't really have to communicate with other aspects of a program. So you can write unclean code and still be okay with it. Another thing that you could obviously do is obviously add more features. I'm gonna try to do it right now only. I just want to check how long I've been going for. So I've been going for 56 minutes. Did we actually get any concurrent views? Okay, we didn't. All right. Okay. So yeah. So basically, that's kind of what we have. Now, obviously, couple of things I want to add to this. First off, I want to get a theta, and I want to print out what the velocities are going to be. That's the two features I'm gonna add. Other than that, I also want to add a kind of a trajectory predictor. So I want to use the equations and the velocities that I have over here in order to actually predict a actual sx and sy. So I want to get like a maximum height and a maximum displacement. Those are the two things I kind of want to predict using, because technically we do have all the values required to make a prediction like this. So I think it should be doable. So alright, so let's actually try making prediction like that, because it would be very cool to, because basically this is a really cool project that we've made, and I'm gonna tell you why. Because this project has a lot of real life applications and stuff. Because I mean, I don't know how many of you actually watch Mark Rober, but if you do, you'll see that he made kind of like this basketball net that kind of travels. I'm sorry, not basketball. He made a dartboard, and basically you throw a dart, and the dartboard will kind of automatically shift and just position itself in the correct place, and you can kind of, and so you can be like very very good at darts. Now, that project is basically just projectile motion, because if you have a projectile and it's moving, and you can figure out what the equation of its motion sort of looks like, then using those methods you can actually plot like a trajectory. Because I mean, you aren't going to be throwing darts from like 100 meters away, so you really can kind of sort of factor out air resistance, because darts are also like very very aerodynamic and stuff, so you can kind of factor that out. But basically, you can use that concept in order to model a dart shot, and not just a dart shot. I mean, I'm going to tell you kind of a more destructive use case of this, which is a sniper shot. So you can model a sniper shot using code. So if you don't know, snipers, well, they need to kind of, when they are going to be sniping across a very very long distance, in that case it's a very difficult thing for them to do, because they have to factor in a lot of different variables, and gravity, I mean, from the uh, from the movies and stuff that I have seen, and from the series that I've binge watched, I think that gravity is like the biggest, I would say, sniper obstacle. Gravity, and I guess winds. So, I mean, I'm not accounting for winds here. I'm only accounting for gravity, but whatever. All right, you know what? That's enough talk. Let's actually get the feature in place. So for that, we're always going to refer to the math that we had done previously. So I'm not going to show that to you right now. I mean, we already have it in place, so I'm just gonna use it. All right, so we have all of that in place, which is awesome. So we have one tiny error over here, which is the fact that I am getting val x and val y, which is with respect to. Okay, you know what? I think it should be good. Okay, what we're gonna do is we're gonna get max dist based on the angle, and we're gonna calculate that real quick. So we can just do a 2 times well. I'm gonna put that in a bracket. Actually, we can just yeah, no, that's good. Times math dot cos theta times math dot sine theta divided by gravity. And another thing I'm gonna do is I'm gonna do a val okay, so in this case it's gonna be, so how do we actually get the scaled velocity? Well, scaled velocity is just gonna be val x over 10 the whole square plus val y over 10 the whole square, right? So it's gonna be the whole thing divided by 10. So we're gonna do val divided by 10. So now we can print out the max test. Print max test. Nice. So this gives us a sort of a, should I say, alright, I'm gonna have to do this like this. Alright, again, get sort of a maximum distance. So we can see that at one point, oh yeah, the maximum distance is going to be very, very small because we are looking into account of x distance, and at y, so I can see at this it's going to be maximum, as you can see. Alright, okay, so for now what we're getting is the maximum distance, and it's good, but there's still a problem with it. The problem is, well, we are getting a maximum distance, right? How what we are getting is actually being followed. What I mean to say is, well, coordinate system, as I said in Pygame, is a bit weird. So what I'm gonna do is we're gonna go ahead and okay. So the first thing I'm gonna do is I'm gonna figure out exactly what the ball x is. So it's radius times 20. So ball x I'm currently setting at 200. Alright, so I'm gonna write that down somewhere. I have a whiteboard in front of me, so I'm gonna write it down over there. I'm gonna set the initial ball x to 200. So now what I'm gonna do real quick is we're gonna get the max test. So basically we're gonna clear that out, and what I'm also gonna do is I'm gonna print ball x. Alright, nice. You're gonna be kidding me. Max dist x. Alright, so obviously it's too much right now. I'm gonna do somewhat like this. Press space, and there we go. So it's 719. That's the new one, and our max test was predicted to be 480. So we can do a simple 719 minus 8200. I want to figure out if there's some sort of a systematic difference. So we're getting 519 as our max distance. We predicted it to be a 480. So now I need to know, why did we get that? Why did we get max test as 519? And I pretty much know the answer to it. I immediately got to know it, like, not immediately, but I kind of got it. Basically, we are getting 480, and it's good. Actually, nah. I don't think that's the answer. Okay, it really should have been 519. I don't know why it's not. Maybe it's some problem regarding how I'm scaling everything up and down, because I mean, I'm just maybe not accounting for a lot of stuff that is going to be happening. Because we are close. I'm not saying that we aren't close. We are close to what the answer should be. Because if we weren't close, then that would be a bit of a bigger issue. But the fact is, we are pretty close to what the answer is. So that's another thing. Alright, so let's run this again. I'm gonna do a different kind of an angle this time. We're gonna do something that's a bit more vertical. So this time the distance should just be 260. I'm just gonna write that down. So 260. So really it should just stop at 460, but it stopped at 469. So that's a bit of a... So basically, I guess it's like it's giving me a very close answer, but it's not exactly there. And I guess the reason for it is gotta be in the fact that I'm guessing it's because of some of the approximations that are being made wherein we are doing like sine and cosine. I guess that's the real issue. I'm not sure. It could be that. I'm not very sure about this one. But for now, you know what? Let's just roll with this. I mean, it is a decent approximation. So yeah. Alright, so now let's figure out max height. So we can do max height. Max height is well, times 2 times math dot sine theta times 2 divided by 2 times gravity. Alright, that's awesome. Alright, awesome. Alright. Okay, what we're gonna do now is we're gonna do another thing. So we're gonna do if ball and yeah, I think that's good enough. And also what I'm gonna do is I'm just gonna break. Alright, and we're gonna also just print out max height. Awesome. Alright, so let's do this. Yeah, a max height. Let's run with a 36 max height. Yeah, that seems good. Okay, so we get 590. Okay, wait a minute. I think we're making some kind of a error over here. Okay, so ball y change is actually not ever reaching 0. Alright, so I need to check, like, if ball y change is greater than or equal to 0, I'm gonna break out of the loop. So it should break out like exactly when it reaches greater than 0. Alright. Okay, let's try to do 36 again. Maybe we can get that. Please. 36. There we go. Nice. Space again. And there we go. We get 533 point something. Well, I mean, we have this 36, and we should. Okay, so where did we start the ball Y? That's the question. So ball Y was at height minus radius times 3. Height was at 600, radius was 810, so we start it at 570. So it ended up at 533. So if I do a simple calculator, 570 minus 533, what do we get? What do we get? Wait, 33, 43, 53, 63. It's 37. That's pretty much what we want. Awesome. So we actually get max height. That's so cool. Yay. Alright, so we have max dist x, max height, and velocity and theta. We have everything in place for this to actually be called like a projectile motion simulator. It's so cool. I really like it, and I hope you do. I mean, it's again, you can obviously add more features to this, and power to you, because you should absolutely do it. I mean, if you like this project, you absolutely should add features to it. As you can see, it's not a lot of code in terms of like just absolute number, but we do use a lot of really cool math, and I hope you actually understand what the math is. And we are using calculus. I mean, we are not actually explicitly using calculus, because we are just, I mean, plugging in the actual answer. But this should give you a decent understanding of how you can actually combine math and code into something that's really beautiful. Because apart from just having like simple jumping, it's always cool to have some tiny addition, and it's always these little tiny additions that separate a good programmer from a great programmer. So if you really want to be a great programmer, then you should look at these tiny changes, and you should give the world to them. You should try your best to add them to whatever program it is that you're building. So alright, so I'm not really gonna take a lot of time now. Obviously you could add it in as a font in Pygame, but again, that's more of like front end stuff. I don't really care about that. It's up to you. My goal was to actually get an answer. How you want to use it, it's up to you. So I'm not really gonna concern myself over that. Alright, so I hope you enjoyed this stream. I had a lot of fun recording this. I really wanted to do this project, and managing to do it in front of you guys, it's just awesome. So and it has been a while since I've coded, because I've been busy with a lot of exams and stuff. Finally, I'm done with them. I'm so happy to say that. So yeah, pretty much. So I think I'll stream again, or maybe I'll record a video and upload it if I can, because first I had academic commitments. Now I have like chilling commitments. I have to play and stuff. All right, so whatever. I'll still try to put out videos a bit more frequently, or maybe stream more. I think I might stream, because it's just very hard to actually make a video and then upload. I kind of get bored of doing that stuff, so I'm just gonna go ahead and stream, because then it's no turning back. So yeah, so that's pretty much it for this video. I hope you enjoyed it. If you did, like and subscribe to the channel, and comment down below what else you want to see, what other streams and stuff you want to see, and I'll try my best to put something together for you. So that's it for today, guys, and I'll see you in another video or another stream.